Okay, so we've got a question here involving probability, and it asks us to work out the probability that t is an odd number, and it's telling us that they add together the three cards. So we're picking three cards. There's lots of ways of doing this. We can do it through logic. We could try and work out every combination going. That will add up to give us an odd total, because it wants the answer to be an odd number. Will work, could take time though. So lots of information here, lots of space. Although it's three cards, three things happening here: picking a card, picking a card, picking a card. Then I'll draw a tree diagram and think to myself, what are the conditions I want? So let's have a look. So the first pick then, so the first card, what could have happened? Well, it could have been an odd number, or it could have been an even number. If I look at the numbers available, what's the probability of getting an odd number the first time round? Well, there are 1, 2, 3, 4, 5, 6 out of 8. And coming from one event, the probabilities have to add up to a total of a whole 1. So if that's 6 over 8, that must be 2 over 8. And we can see it's 2 anyway, because there's two even numbers there, and 2 over 8. So we could have got an odd number the first time round. What could happen with the second card? Well, we could have got an odd number and an even number. If we got an even the first time, then we could have got an odd and an even. But we've got to remember with this is that once we've picked a card, then the probabilities now are going to be out of 7, because we've got one card less. If we picked an odd number, that means we've already used one of those odds, so that'll be 5 over 7, so this must be 2 over 7. This branch here says that we picked an even number first, so there'll only be one even number left, and it's out of 7. So if that's 1 out of 7, that must be 6 out of 7. So we could have picked an odd number followed by an odd number, and for our third card we could have picked an odd number and an even number, and if we picked an odd number there, then that would mean there'd be 4 left out of 6, so this must be 2 out of 6. And so far we picked an odd followed by an even, so there's only one even left now. So our even would be 1 out of 6, that means our odd must be 5 out of 6. And if we've gone to this one, then we've picked an odd number, so there is one odd number less, so that's 5 over 6 left, so that must be 1 over 6. And if we picked an even that way round, then we picked even, so that means there are no even numbers left, so that's not possible. So that means if we picked even followed by even, then the last one must have been an odd, so the probability of that is a whole 1. Okay, so now we've got to go through thinking to ourselves, well, it wants a total of an odd number, so the total must equal odd. So we've got to go through the logic of what happens here. So if we get an odd number followed by an odd number plus an even number, that will give us an odd number. If I give an example just to show you how it works, 3 plus 3 is 6. Oh, that's not an odd, it's an even. Okay, so odd plus even. So 3 plus 3 plus 4 is even, so that'll give an even number, so 10. So odd plus even gives you that. Odd plus odd plus odd. Well, odd plus odd plus odd will give you odd. Again, 3, 3, 3, 9, odd. Even plus odd. So what we got? 4 plus 4 is 8, plus 3 is 11, so it's going to be an odd number. Any other combinations that we have to think about? Well, we've got 1 odd and 2 even. We've got 1 even and 2 odd, and we've got all 3 odd. We could have had even plus even, and that would have given us an even number. So is there anything else that would give us an odd number? 1 odd, 2 odds, 3 odds. No, I think we considered them all. Okay, so we want an odd total. So 3 odds will work, so that will give us an odd total. 2 odds will not work, so coming along here we'd have had an odd followed by an odd followed by an even. So odd followed by even would be even, so that wouldn't work. Going along here we'd have had an odd plus an even, that would work. That would be odd, by the way. There was odd, even, odd, so that didn't work. Here was even, odd, odd, so that does work, because even, odd, odd. No, that doesn't work. So even, odd doesn't work. Even, odd, even does work. Even, odd doesn't work, and even doesn't work. Okay, so we've got these 4 conditions that work then. So odd, odd, odd. So odd, odd, odd. We want that one, and that one, and that one. So we've got to remember that when we want something and something and something, we times the probabilities. So that's going to be 6 over 8 times 5 over 7 times 4 over 6. So 3120. 8 7s are 56 times 6 is 336. Okay, so that gave us one condition that worked. But we also noticed that we've got other conditions that work. So odd followed by even followed by even. So odd was 6 out of 8 first, followed by even, followed by even. So 6 times 2 is 12, times 1 is 12, and that's going to be the same as the other one, 336. So that's done that one, So we've now got this one. So we had even followed by odd followed by even followed by odd followed by even. That worked. So that was even followed by odd followed by even. So that's the same as that one. So that's 12 out of 336. And then we have the last condition that worked. So even. So we're now writing down all the conditions that work. So we had even followed by even followed by odd. So that gave us even followed by even followed by odd. So that gave us 2 over 56. So 2 over 56. Because I'm working in 336 with all of those, I'm going to make this one 336, which was times by 6. So that's the same as 12 over 336. Okay, so that gives us all of these possible things that work. So we can have this one, or this one, or this one, or this one. So or means that we're going to add those all up. So we've got 120 plus 12 plus 12 plus 12, 36, 156. So 156 out of 336. So our final answer here would be 156 out of 336. Again, we'd look to see if this cancels down. Well, they're both even, so that's going to be 75, 78, and that's going to be 150, 168. Both even again, so 39 over, so that's 39, and that's going to be 84, so 39 84ths, so 39 84ths. Okay, so that would tell us the probability of getting a odd total. Again, it was quite a lengthy question. It was worth 4 marks, so you have to spend a bit of time on it. But it is about thinking through the logic of what happens, thinking about what 3 cards do to give you an odd total, and then thinking through the combinations that would give you the total, and then thinking through that because you want something and something and something, they're independent from each other, so you multiply the probabilities, and then that one would give you an answer that's odd, this one will give you an answer that's odd, and so forth. So because these ones all count, or plus, or plus, or plus, add them all together, we get this total, and that would be the probability of getting an odd total.